Okay, let's get going. Folks, so any update from anyone on trying this? Any experiments people have run on this competition last week? Arto, were you able to get any submissions or make any attempts?
No, not really. I have just explored the data so far, so not much on my side.
But you, Jack?
Yeah, I tested a bunch of things. I can show you. So I tested on a small diverter and just on 1/10 of the essays from the provided training data, and so basically, if I do that, the training time is about 25 minutes, which seems like a reasonable time for testing. And for that, the batch size is 8. So I always try to use as large a batch size as allowed by the memory. And then to this, I started adding various things that are meant to help with training. And the first thing I added was stochastic weight averaging. And so that doesn't really change the batch size. And then to that, I also added some gradient clipping, and then I used.
Sorry. So could you expand on what you mean by stochastic weight averaging? Is that, I'm not familiar with that technique.
Stochastic. I'm not entirely sure. Maybe like Arto or someone else can explain it better. But
Arto, do you know what that methodology is or technique is? The summary of it, if you will.
I'm not quite sure what exactly. I know it's like a popular technique is to average kind of bunch of checkpoints. Say you have take last 3 checkpoints and average the weights. But yeah, I'm not sure if that's the thing. So.
So in your application or where you implemented it, or was there any paper reference or any notebook reference, Jack, to this particular method
so for
where
this,
they implemented this?
For this, I just turned it on in PyTorch Lightning. Yeah, so
I see. So it's a feature in PyTorch Lightning that can be turned on or off.
Yeah, but I've seen this mentioned like quite often, and I think it's been around for a while now. So I'm sure you'll be able to find some
something
more
right upon
in-depth examples. Okay. Yeah, like on Kaggle. Yeah. So and then so the point of me like adding all these things to this first example is just to check that nothing is obviously like erroneous, or like there's a lot of like adding these things does not introduce like unreasonable instability in the training. And so and yeah, so afterwards I used mixed precision training. So using this allowed me to increase my batch size to 12. However, like for some reason, the training time.
Now, sorry, again on this, when you do precision 16, so it's basically, are you using the PyTorch AMP or that kind of ability to use the reduced precision rather than full 32-bit precision? Is that so? Does the notebook use AMP, PyTorch AMP, or something like that, or do you know?
So I guess so. Again, this is something I just turned on like in PyTorch Lightning, and imagine it uses this MX Apex NVIDIA Apex to do the mixed precision.
And this is all in PyTorch, correct?
Yeah, I mean the detailed implementations like are in PyTorch. So so there are somewhere in PyTorch Lightning's source code, basically.
Yeah, in fact, you know, the notebook you pointed to last week, I think on the optimization, that's really excellent because it kind of gives you kind of all the different steps to really reduce the performance, or not reduce performance, actually reduce the execution time or runtime of training, which is why I'm kind of surprised that your runtime when you switch to 16-bit precision doesn't change at all, pretty much.
Yeah,
but,
yeah, I'm slightly like perplexed by this. So I would have thought like if when you increase the batch size, the runtime reduces, or at least like kind of that's what I thought. And
in my experience, the mixed precision, it very much depends on the GPU you use. So at Kaggle, we usually have this P100s, right? That are kind of oldish GPUs. And
that's probably it.
Yeah. And maybe another factor here.
Okay. Because I was sure.
Yeah, that's a good observation, Artur.
Yeah. I mean, before it decreased the training time for me, but it's just like in this past week, I couldn't reduce the training time, and I didn't know why, and I didn't. Yeah. So yeah, thanks. I didn't know about this.
Do you know off the top of your head, Artur, whether the P100s have the tensor cores or not? I don't recall that off the top of my head.
Yeah, I'm also not sure. I just I really didn't track that much this information because yeah, but I just remember that I observed, you know, I was using different GPUs and observed that the difference in training time was like different when you use FP32 and FP16. So some GPUs like have comparable like runtime on FP32, but when you switch to FP16, you get the speed up on like some but like better ones. But yeah, I cannot really tell which ones exactly are the best. Also, I've looked up the stochastic weight averaging, and that's very similar to what I thought, but you do it during training. So you have like instead of so after you do the weight update, you keep the old weights of the model, and you do this basically like exponential moving average seen with the weight. So yeah, the formula would be like you just take you have some like step and update the model, but you just add old weights times some number plus new weights divided by the number of those models. So I hope that makes sense.
Yeah, thanks.
Okay.
Yeah, I guess where I guess where does the stochastic comes in. Yeah, but I guess doing the averaging makes things more stable. Right, and so so using mixed precision, the batch size is 12. Then I added a gradient checkpointing, which I mentioned before, which is another trick to reduce your memory usage. And doing that, the batch size can be as large as 32. And again, the runtime does not reduce doing this. And then a bit further, like using the 8-bit optimizer, which is the one where you need to install bits and bytes. The batch size becomes 38, and the runtime is still roughly the same. And then I added gradient accumulation, I guess. That doesn't change the batch size, and the runtime is roughly the same. And so I guess like the main motivation for me to doing these experiments is just to check things seem stable. So here, if you see, here's the train loss, and here's the validation loss, and like all of these runs listed in the table here, and they all seem to have kind of similar trend. So, which seems to suggest that it's probably safe to add all these additional helpers, like in my in my experiments that I will be doing.
Quick question to actually anybody, because I think I also looked at these techniques. I haven't tried them in the notebook as they're going through the notebook, trying to understand where they were implemented. So one question I had, maybe you or Arthur or somebody can explain the difference, or in fact specifically what the technique of gradient accumulation does, and how that helps reduce potentially the runtime. I can understand, the rest of the techniques, 8-bit optimizer, using mixed position, even the weight averaging, but I was somewhat at a loss about the gradient accumulation.
Right. So
and
just to clarify,
how that reduces.
Just to clarify, like for memory usage reduction, so like mixed precision, gradient checkpointing, 8-bit optimizer, I guess these are the methods that are supposed to help with memory usage. The others are more for improved training stability. So not everything applied here is to do with memory usage reduction. So
right, that's true. Also, sometimes it's speed of execution, right? Like, meaning you can speed up because, for example, the mixed precision and the 8-bit optimizer, not only does it reduce storage, but it also, provided the hardware supports it, also helps in speed of execution, because if you use 16-bit or mixed precision, then you can do more arithmetic in a given time, because the same multiplier accumulators can support more, in some cases as much as 2x the throughput that you would have with FP32. So you're right, not everything only contributes to memory footprint, but also helps the speed up, which is somewhat related to the runtime reduction. But I just didn't or don't yet fully grasp the gradient accumulation part. So Arto, you have or Mayank or anybody else familiar with the gradient accumulation part and what impact it has on either memory or speed up?
Yeah, I can explain this if you'd like. So basically what gradient accumulation is, we do like loss computation, then the backward pass, and then we do not update the weights. So we do not do the optimizer step. And the gradients are stored. So for each tensor that is weight tensor, we have a corresponding gradient tensor, right? And when you do the gradient accumulation, you do another forward and backward pass. And for example, here, where we have a step 2, so every 2 step we will do the optimizer step, which will compute the weight update. So that would be gradients multiplied by learning rate, and then it will update the weight. And yeah, that's basically it. So we do optimizer step every gradient accumulation step times often. And in this way, what effectively this would be the same as using twice the same size the batch size. So for example, if I use batch size 16 and I do the gradient accumulation step equal to 2, then I have effective batch size of 32, and I can use a slightly higher learning rate as it usually works with that, and I have the basically all the properties. So mathematically, it should be identical to using batch size of 32, just the same thing. And yeah, that's basically it.
Okay, and in relation to gradient checkpointing, then is it just, what does that do? Is it
okay? So gradient checkpointing is a completely different thing. So it works for when we have like some let's say some model of say 2 layers. We to do the backward step, we need to store the intermediate computations for the backward step. You know, depending on what the layer is, we will use this when we do the backward pass. When you activate the gradient checkpointing, you do not store this additional information, but you will recompute it during the backward pass. And in this way, you can basically load much larger models. So you can use much larger models, but it will be slower. So it slows down the computation. So kind of the same model with and without gradient checkpointing would be, with gradient checkpointing, it would be slower, but it allows to use larger models.
So basically, typically we would store the forward pass calculations in order to make the backward pass faster and reuse the stored data. But in this case, we flush that. And yeah, I think I remember now, I saw the example where you may not even flush everything, but you flush the prior ones, and that helps you save memory storage, so you don't run out of memory when you're using GPUs. But as you say, you pay, it's the traditional hardware trade-off of memory or storage versus compute. So you have to compute more because you use less storage. And you can see that in what Jack is sharing too, right? It increases the runtime by about 6 minutes.
Mm-hmm. Yeah. Exactly.
Okay,
I think
thanks.
now all Hugging Face models, they support gradient checkpointing, so you can do that with all the models, and sometimes you just cannot do this computation without gradient checkpoint and for a larger model. So that's the case when you want to use it. But otherwise, if you can fit the whole like forward backward pass into memory, then you probably don't want to use it.
Yeah, got it. Thanks. Yeah, I think now I recall that, and thanks for your explanations. That helps.
No problem.
Okay, thanks. Right. So so I will be using all these tags for my future training, and one thing that I noticed was that the validation loss, they tend to increase while the training loss decreased, and this kind of suggests some kind of overfitting. So I included more input text for the transformers. Up here for these runs, I was just using the discourse text from the data provided, nothing else. And so I tried adding different bits of text to the transformer input. So before I was just using text, and then I added the discourse type, and then I further added the essay, and then I also tried grouping the discourses by their type and the essay they belong to, and then I sort of joined together all the, I guess, all the discourse text from the group, and then added that to the transformer input. To be honest, like, I don't know if you can really conclude much from these numbers. So when I was just using text, the training loss, the final training loss at the end of the training was about 0.38. Validation loss was quite high, about 1. And as you see, as I added more information to the input, this gap reduced. But like, if you look at the actual curves, there's actually a lot of fluctuation. So yeah, I don't know. And it also depends on your definition of what overfitting means. But it seems like here, like after adding more text to the transformer input, the validation loss has decreased, because like here they are no longer larger than 1, whereas like before they kind of they went over 1. Yeah.
Yeah, one of the techniques I saw in one of the notebooks you had referred to last time, that the one which really does EDA plus training example, he does something called multi-sample dropout. I haven't read the paper. He also provides a paper reference for it, and apparently that way he tries to address this overfitting. I don't know the specific impact. He hasn't done any kind of ablation to show whether the multi-sample dropout is helpful in addressing the overfitting. But yes, many people have commented and shared what you're saying, right? Like that whenever the training loss continues to go down, but validation loss begins to increase, then if we define overfitting that way, then there's definitely the issue of overfitting very quickly. So the one thing I've seen is this technique of multi-sample dropout, that I'll provide the link and the notebook that implements it.
Yeah, okay, thanks. Right, so So another thing I tried after this was to try to freeze some of the transformer layers. But so basically, so for example, like if you see on the top here, I'm just using as input type text essay with no frozen layers. And so the training loss is this, validation loss is this. And when I freeze layers 1 to 3, the losses become these. So in this case, it's not obvious that the gap between them has reduced. When I freeze layers 1 to 4, you can see, well, these are the losses. And again, like using different text inputs, I've also tried using frozen layers and models without frozen layers. And I think like in general, like the gap between the training loss and the validation loss is reduced when you use frozen layers. But yeah, so like the question I have is, which maybe Ato can comment on, is like with transformers, like how does one normally freeze the layers? Because I know like if you're using a CNN, you just sort of freeze. You want to freeze the earlier layers and train the latter layers. Is this also the case with transformers, or it's more it's different? You need to be more careful about particular modules inside each layer to freeze instead, rather than sort of naively freezing like the earliest layers.
Yeah, I think if you want to freeze the layers, freezing the earliest layers makes most sense with transformers as well. Also, another thing you might try, you can avoid freezing layer norms. So even if you freeze a particular layer, don't freeze the layer norm layer in the layer.
Okay, why is that?
So basically, I don't have like good explanation in terms of theory, but there are papers that show that only fine-tuning the layer norms, you can achieve good results in some tasks. So basically, I guess the reason here is that this computation that attention module does, and so the layer norm can introduce enough flexibility to tuned for the task. But yeah, I might can find this paper and send the link to you if you'd like. But other thing that you might want to try is, instead of freezing part of the layers, you can do this adapters. I don't know, we probably talked about it briefly during the last competition, right?
Abductors, you said?
Adapters.
Adapt. Oh yeah, yeah. I think you mentioned them, but it sounded quite complicated. Yeah.
Okay, maybe I will create a notebook for this competition, and that would be a good motivation for me to start with it finally. All right. Yeah, but so basically what adapter does, instead of, so you keep the layers frozen, but you have like a small additional weight for each layer that you fine tune. So that's yeah, so that's another option. Important thing here that I actually haven't saw a strong evidence that freezing the layers is a good strategy for transformers. So I think the most popular thing is just to fine tune the whole model. And yeah, so for example, now you are using like a smaller subset of data, and freezing layers might be helpful because you have like a very small amount of data. But once you
yes,
add the data, it might change. So
yeah. About the adapters, do you mean like this thing called weighted layer pooling by any chance?
oh, not
no, it's not like that. Okay.
These are modifications of the actual weighting that of the layers themselves.
Okay. I don't think I've seen it. Yeah, it would be interesting to see how it works, how to implement that actually.
Oh, so as weighted layer pooling, it's like a head, right? So you modify the input to your classifier instead of taking like the last CLS embedding, you take more, right?
Yeah, you take the CLS from all the layers instead. Yeah. Okay.
Back to the freezing. I think the couple of notebooks I've seen are though they implement freezing for these large transformers. Like, I mean, both of them that I've seen use the Tiberta model, either small or whatever standard, not the large one. But in both cases, at least in this competition and the results, I mean, they do a bunch of other things too, but the freezing, at least as I understood it, was more backed towards helping speed up the model, because with such large models, people are seeing that when they also include additional data, which I'll talk to in a minute, that I saw in a Acid Jackism on another notebook, that he uses additional data from the same competition that was done either earlier this year or last year, but with similar essays. So he can just import that data, and it has the discourse type annotations and stuff that you can just use. And because of the model size and the data, the model size, they try to speed up the model again. Among the techniques, the Jack was going through, freezing the layers is also another one that they try to implement, mainly to address that part that, it gets too long. And if you run the inference, it exceeds the 9-hour limit. And that's one reason that I've seen people implement freezing. And at least in the notebooks that I've seen so far, it seems to work okay. I mean, they do get scores in the 0.6x kind of range. It's not the best, because the best is, as of yesterday when I checked, about 0.56. But there are people who are getting 0.62, 0.61 scores while freezing some of the layers, like what Jack has shown here.
Okay, thanks. Right, so after this, I just tried a bunch of things, including adding more training samples, and then also using that dropout pooling that Shravana's mentioned. And, like, I don't really want to conclude anything from the results here. There just seem to be a lot of instability or fitting here.
Jack, quick question. Were you also already implementing the couple of other things which are fairly trivial to do, as I understand it, so the fast tokenizing type of thing when you tokenize?
Yeah.
Because that is simply a matter of turning on some flag.
Yeah, like the
fast or something like that.
Yeah, like the easy things, like I've done them basically. Yeah, so
and dynamic padding as well.
By that, do you mean just like padding to the longest sample in the batch?
Yes.
Yeah, I do that as well.
Okay.
Yeah. So anyway, so I also tried sort of clustering the essays using BERT topic as shown in one of the public notebooks. And so using BERT topic, I found 17 clusters of essays. And the count here is like the number of essays belonging to the particular cluster. So each cluster is a topic. You can see here, so there are, well, yeah, you can see here some of the topics, different topics. -1 here means like you should ignore it. It's probably not a good cluster. And you can see actually it's school fun people get. So I guess it doesn't make sense here. And right, so so I'm thinking of using these clusters to group the discourse texts or the discourses in the training data, and then try to do something similar, like that was found to be effective in the US patent competition. But I don't know if it will work well yet. And I need to try.
Yeah, I think in that one notebook you had pointed to, I think I forget now the title of it, what it is called, but yeah, he does use the topic like you're doing, or feedback price, the complete overview. That notebook which has EDA and then the full training, he uses the topic extraction based on what somebody had done on the 21 or the prior data set. And the reason that apparently this helps, I dug into some discussions, and apparently the reason that this helps somewhat if you use this is because the topics are somehow, now stepping back, the competition gives you essays from grade 6, I believe, to grade 12, if I'm not mistaken, or it's a wide range. And what the topics somehow seem to point towards is it seems to be able to help the model differentiate between which topics higher grade level students are assigned and lower grade level students are assigned. And the way indirectly, and this is all speculation in the discussion, but just as a FYI as to why the topic should help in better classifying what we are after, is because the implication of the discussion is that the topics help to segregate the essays, and that in turn helps you because at the higher grade levels, there's a better chance of the arguments being, effective or, adequate rather than ineffective or something like that. Therefore, if you're able to, from the topics, figure out which topics are given to higher grade levels and therefore are indicative of a higher grade level, essay, then that helps you. And at least in the discussions, that's the speculation that I saw as to why including the topics into your model seems to help the model do better.
Okay, that's interesting. Can you share like the link to that discussion?
Yes, I'll have to dig it up as to where I found it, but yes, I'll do that when we are done and I go back to the discussions. Yeah,
so I want to mention that how to use the topic for clustering the essays is shown by this by Sindhu V in her notebook. Yeah, she applied it to the data from the previous competition. Yeah, but I was thinking like at test time, you will need to apply this to the test set, right? In case there are new topics there.
The feedback price notebook does that.
Okay.
It extracts the topic of the current competition because you'll have to do that, as you rightly pointed out. He actually does it in training too, now that I remember it, because you need to do that if he combines the data, as I said before. He concatenates the two data, two pandas data sets, if you will, the prior competition and the current competition. And that, so he would have to do it to generate the topics for the test set as well.
Okay, yeah, thanks. I just want to mention, like, this past week, I've been getting a lot of this message, which had not seen much before. And so basically, Kaggle was like getting so busy that you have to wait for your notebooks to be saved. And yeah.
By the way, any way in Kaggle, like in Google or something, to switch your geography? Is it a geographic problem?
Well, I don't know how to.
Like if you're in APAC and lots of people there are kind of using, and if you, I don't know. I'm just asking as a workaround to see. I haven't seen anything in Kaggle which lets you do it. I mean, I think in Google or in OS, you can kind of choose the geography within broad segments of which one you use, but I don't know that there is anything like that in Kaggle because it's all free. But I was just curious.
Okay. Yeah, I just hope, like, as if Kaggle is becoming more and more popular, at some point in the future, they will reduce your weekly quota to 15 hours or something, or.
And that'll be a pain. Or you'll have to run it, download the data, and do it on Colab and such.
I don't know. I think
And,
Kaggle is popular, has been popular for quite a while already, right? So they are doing fine.
Okay, yeah.
I don't think that, but I don't know. I haven't seen any like numbers. Maybe really more people are getting involved, but yeah.
Yeah, I have noticed there's a ridiculous number of entries for the American Express competition. I think it's over 3,000 now. So maybe they are causing this message to appear. But
yeah, but
anyway.
it has a lot of money, and I think job prospects at the end of it too, right? Like they said, if you win, you're likely to get, in that competition, you're likely to get job offers too, because if they use your thing, they also want you working for them. So a lot of money involved.
And that's probably a good thing to have in your portfolio for like, that's like popular application of machine learning in industry. So yeah, probably that's why people are cheating.
Oh yeah, definitely. So thanks, Jack. That was very insightful. And let me share my screen so I can talk to a particular stuff that Jack had shared. So let me know when you can see my screen.
Yeah, I can see.
Okay, so this is the one that Jack had, the notebook, and this notebook has much of the some of the things that Jack had pointed to. I mean, the first part is all EDAs and kind of, just scrolling through it. He provides a bunch of stuff, but the important thing here is there is the feedback prize from 2021. This is the prior competition. There, the goal was named entity recognition, but the data set is available and it includes 11,400 additional essays. If I recall, the current one is like 4,900 or something, if I'm not mistaken. So, and 70,000 additional, discourse annotations, if you will. So that's kind of the thing where adding that much amount of data can really kind of help as well. And he adds it. I'm going to skip through some of earlier. He just does a lot of, and he provides some nice visualizations of the essays, blah, blah, blah. And here is the 4.1 number of unique essays is 4,100. But as you can see in the prior competitions, they provided almost close to 3 times this number. So that's, I'm sure, really helpful. And this is the topics and the prompts. And as you can see, the author of this notebook, he says that he's joining it in the competition data set. And then this is all, distribution, EDA type stuff. This is somewhat interesting that the author has provided, right? Like it's discourse type, but then within each of the discourse type, what's the distribution of the argument's effectiveness? So you can see the distribution of the effectiveness for each of these types, which leads me to one particular, and again, I don't know whether I have easy access. I have bookmarked it somewhere. I'll provide that. One of the techniques, anyway, let me finish this and I'll share another thought or suggestion that a person had, which could potentially improve the scoring, but I'll get to that after we go through this notebook. So all I did last week was just try to understand the implementation of this notebook. Data's examples, these are just visualization of the example. This is just word count of the various discourse types. And here is where he generates the data from the 2021, and actually he makes predictions for the 2021 data. Right, based on the 2021 data, he makes predictions of these categories, if you will, that we are after in this competition as well. Again, most of this is EDA. This is where he's kind of creating the stuff. Another interesting thing he does is he uses some level of label smoothing. But what is strange is while he says that he's doing some label smoothing, the label smoothing factor here is, in the notebook at least, that setup is 0. So I'm not sure whether he's actually doing it or not, because he doesn't change this subsequently. So that's one of the things I want to check when I run this. He uses stratified k-fold, then does the tokenizer, and this is the fast tokenizing flag that I was referring to earlier. He just loads up the essays, tokenizes, and this is something else I saw, which Atto, you may be able to comment on, and I don't know whether Jack, you saw it anywhere else. But one of the things he says is, how we have seen even in the last competition and this one, you concatenate the various parts, like here is the discourse type, you have a separator token, and then the topic name, and then the discourse text. And this is where he uses the topic name and why the generation of topic is included, or how the generation of topic is included. But what is fascinating to me is he says that if you give the input as what he calls a text pair instead of just stringing. So Jack, for example, in your notebook, I assume that you're just strung the essay text along with the rest of the pieces, correct?
Yeah.
And he seems to suggest in the notebook that providing it as a text input pair somehow gives a little better performance. Have you seen this, Arto, in anything else in use of transformer? And I have not seen that you can give a tuple of inputs to a transformer model. I mean, of course, both are tokenized, so it's just a tuple of tokens. But I'm somewhat, this is the first time I've seen a tuple of tokens input versus just a token.
Yeah, if you remember original BERT paper, there was this additional pre-training objective where you have two sentences, and you classify if those two sentences are like consecutive or not, or something like that.
Correct.
And,
yes, they follow each other or not. Yeah.
And in other papers, particularly Roberta, they removed this pre-training objective and said that this works better. So the difference here would be we have token type IDs, and that would be like 0 for sentence 1 and 1 for sentence 2. So we have like additional embeddings for two different, for first and second, let's call this parts sentences, right? So the first text and second text, but it's not there. It's not there for all models. So some models have it, some models don't have it. So what will happen internally here? I believe it would be this first text and second text are concatenated with separated token in between. And that's it. But also we have this token type IDs that are that indicate is it the first sentence or the second sentence. And yeah, definitely in some cases, so like here, it might be useful, right, to indicate for the model that this is a text we are interested in, and this is a text we don't care about. But that is only relevant if the model utilizes this token type IDs at all, because some models just do not have that feature.
Does the token type ID also has a kind of an effect on what the output will be? Sorry, if you guys can hear me.
Yeah, I just haven't understood really what you meant.
Let me rephrase it. I was asking with respect to token type ideas you Arto just alluded to earlier. Do we have some kind of a difference with respect to, for example, if we have a 0 or a 1 in the token type ID, and will that have an effect on the execution of this statement?
Yeah, so this token type IDs, if so for example, the original BERT, it has like token type IDs embedding. So the token embedding would be like an embedding for this particular token, right? Plus the positional embedding, plus token type ID embedding. And therefore the same like sentence being in the first or the second part would have slightly different embedding depending on what the model like assigns to this token type IDs, right? And that will propagate through whole computation, right? But that's relevant if the model does have this token type IDs, and some model, I don't know if all models like use that if you provide it. So maybe, maybe some models do not use those even if you provide it.
Okay. Got it. Thanks.
So, so your guess, Arto, is that this way of providing tuple of tokens is another way of identifying or helping the model identify or generate this token type IDs, and that's potentially a reason why it does A, it accepts inputs in this form, and B, the model may be performing a little bit better according to the author with this kind of input rather than just stringing it all together, which would just include a separator token, but no token type ID separating the two pieces.
Yeah. So that would help the model differentiate between these two texts, right? So like it would be a learnable way to like add some specific flavor to the first text and the second text. And here we are, so the meanings of two texts are very different. So the first one is much more important for the for our final output. So that might be really useful for a model to learn, like indicate that in a learnable fashion. That makes sense.
Yeah. Okay. Thanks. That helps. So that was something interesting. Jack, you may want to try giving inputs this way and see whether your model improves.
Is it using debugger here?
Yes.
Okay.
You'll see it right below. And here is the reference. If you look at this notebook, he provides the paper reference for the multi-sample dropout that he implements. I haven't yet understood or gone through the paper, but there is a reference, you can go through it. And then he implements mean pooling in the head. And he implements this kind of, the dropout variation. And increases, I think, the dropout at some kind of a rate, if you will. And then this is modifying the head. I still have to understand what the token classifier output class does. So he's quite, obviously, based on the coding, he's quite familiar with the internals of the debugger model. So I think it's a good way to push myself to learn the details. He modifies all this and then gets the backbone, then the metrics, and then does the training for the fold. And as you can see, this is where he adds the data from the current training data and the data from the prior competition data. Right, and some of it is based on the basically he inputs a couple of his prior work as reference as well. And here, Ato, I remember you mentioning it, but since you probably know this off the top of your head, what does the data collator with padding do?
So this is the part that will do this dynamic padding. So it will pad the batch to the longest. So
I see. Okay. So this padding longest data collator just basically helps you to implement the dynamic padding on your training.
Yeah. It will go to the data loader as a collate function that like takes the inputs in the original format and outputs the tensors.
I see. Okay, great, thanks. And you can see he uses LR scheduler also. He uses FP16 is true, which means I'm assuming he's also trying to do the mixed precision stuff. And then this is where I think he does this accumulation kind of stuff because he does the evaluation on batch size ×2, but I'm not sure whether this is something different than that. And have to go through it as I run it. He does do gradient accumulation. And then this is where he does the label smoothing. But again, the label smoothing factor would have to be something other than 0 for this to actually have an impact, correct?
Yeah. So label smoothing 0 is no label smoothing.
Yeah. So, and then he computes blah blah blah, and he calculates the validation predictions and does it for all the folds, and you can see that it almost takes him, each fold takes about 2 hours, and he does 4 folds. So it's about just under 8 hours to train the thing. Because at 9 hours you get cut off on Kaggle. And then the interesting part to me also is he goes through the some kind of analysis of course, on the CV he gets a score of 0.61, but his actual score is somewhere, I think, around 0.624. I'm not, don't hold me to exactly that number, but it is in the 0.6 something, 6x kind of range. So in that sense, the validation seems to provide a good indication of what he is getting on the leaderboard as well, right? And then he just calculates some of the confusion matrix. And I think the thing which is interesting is he does identify where the problem is, in the sense that it's between adequate and ineffective, if you will. You can see how much of the problem these two blocks have of incorrect values, if you will, and also somewhat more these two as well. Whereas these, there's less of a confusion between effective and ineffective, but there's a lot more confusion between adequate and ineffective. Or even for that matter, adequate and effective. But I think these are where the significant, and this ineffective is where it really does a poor job. But he doesn't come up with techniques for addressing that, which I think is kind of the interesting part. And then he goes into analyzing, how do you see confident wrong and confident right, which will help you point towards, what you can do to address the issues. But as you can see, what I just mentioned, a lot of it confidently predicts adequate, but actually ineffective, adequate, actually ineffective, ineffective, predicted, and you can see there's a lot of confusion between these two classes. And then he has a separate inference notebook just to wrap things up. But I thought this was an interesting notebook to go through for a lot of the techniques and what Jack illustrated as well. Let me see whether I can quickly point to the one other comment that a competitor had made that I thought was very interesting. I think this is the one. Let me open it and share what I thought was a very interesting.
Hi, could you share the previous notebook?
Sorry?
Can you share the previous notebook?
Sure. Yeah, I'll post a link in Slack.
Okay.
This one, the token classification approach, I thought this was a very good idea. I haven't seen any public notebooks that implement it, but I thought this was an interesting idea, especially because of what he says towards the end. So see, typically what we have seen is this, right, which is just stringing together the different parts. And of course, I showed you a variation on this in that notebook, which is providing it as a tuple combined with the actual essay. In this case, he just strings it together as an essay text. But the interesting part, he says, is instead of doing this, which is just creating a string, maybe what you do is in the essay text itself, obviously the discourse snippets are within the essay text, right? The discourse snippets are taken from the essays and then given the discourse type like lead or claim or evidence, and then they are given the rank, they are given the three classes, adequate, ineffective, or effective. So what he's suggesting is embed a CLS and a separator token separating the discourse text within the essay itself. So he says, here is what you do. You put essay text with CLS and end tokens inserted into the essay itself, and then putting some kind of, ignore tokens, if you will, except for the CLS tokens, and then using those tokens to generate the result. He's saying this is a different idea than what everybody has done. And he provides a base notebook. I haven't looked at this notebook yet. He says, he's too busy, blah, blah, blah. But one of the interesting things I saw somewhere, either in this post or in the comments, is he says that either one of the highest ranked participants in this competition apparently confirms that this technique is what they are implementing. And so it gives, obviously he has not done it and not gotten a score based on this, but he says that, oh, that gives me higher confidence that this method may be something worth trying. So I thought this was an interesting variant to what everybody is been implementing. And I thought the comment about one of the leading scorers kind of backing up these suggestions or saying that, this is, here is his comment. Well, now that the person currently in first place validated this method, I feel more confident that it's actually legitimate. Right. So I thought that was an interesting comment as well, that I don't know how true or not this is, but seems to be an interesting variant, slightly different from what everybody is doing, at least in what we can see in the public notebook versus some of the leaderboard scores, which are about, what if you say 0.6 versus 0.56, about 0.04 or so better. And I'll post a link to this notebook as well as, I think.
And you probably can use the pre-trained models from the previous competition. So this feedback prize, the previous competition for feedback prize was to predict the discourse type. And essentially, I guess you can use the pre-trained model from that one. Yeah, you can do that with all the approaches, but so there it was mostly like token classification kind of stuff, because you want to identify the discourses, all the discourses in the essay, and here you want to use the token classification, so probably that would help somewhat.
Yeah, but actually, I mean, you already know, you don't even have to use the pre-trained model from the previous, because you are given the discourse type and the discourse snippets, right? So it's just a search and match.
That's true, but here I mean, if you want to use some kind of intermediate task training trick, for many NLP tasks, the training, so like fine-tuning model on some intermediate task often gives quite a substantial boost in performance for some like low resource tasks, and that might be like a thing here. Because the data set was larger there, and also the task of predicting the discourse type is arguably a good task that helps the model adjust to the type of text we are dealing with, but at the same time preserving the common knowledge, because it's not very specific task like binary classification or something. So that should result in good models.
I thought these two notebooks were at least quite interesting, along with the technique that Jack shared about how to speed up or use memory better, or a combination of both, the various things that Jack shared when he went through his notebook. So I thought that's kind of fascinating, and I wanted to take the earlier notebook and I'll post a link to both these and then see, once I get that working, if I implemented this variant or this technique, because it's kind of orthogonal, right? That this technique is just a matter of how you generate the input to the model, then whether I can get any kind of improvement, then I can obviously use this notebook as well as a template. So that's
So one comment here on the token type IDs. So I've looked up, and by default, dberta does not use token type IDs. So I don't know how it happened that the author of the previous notebook observed some improvement, but it looks like dberta does not, if you do not modify it specifically for that, it wouldn't use the token type IDs.
Yeah, and also the other even more fundamental simple question I had was, you're now, instead of providing, and this is more a Hugging Face kind of basic model interface question I had, which is, the input is typically a set of tokens, but now you're providing a tuple of tokens. And how the hell does the model just accept that?
Oh, no, that would be a list of or like a single tensor of tokens. Just as well, it won't be a tuple, as you feed two inputs to the tokenizer, but the tokenizer outputs a single array for that.
Oh, I see. So the output of the tokenizer is just still a single stream of tokens.
Yeah. So the only difference would be this token type IDs that indicate the source, if that's the first text or the second is a source.
Yeah, but that is not used. But yeah, so that's where, I vaguely remember that dberta doesn't, but for some reason, the author still seems to say providing it this way, and that was one of the experiments I was going to run, is just simply combining it versus, but again, you have to do it with a lot less text. Otherwise, any of these things takes hours to run. And that's why I think Jack had done the smart thing of doing it on a fraction of the data rather than all of it. So you keep the training time for your experiments small. Reasonable. Okay, that was good. Any other questions or comments from anybody? Yuri, any other thoughts or?
No, unfortunately, I didn't have a chance to work on it this way.
Okay, and yeah, if you can post, I think some of the references you're talking about that, or even take a crack at the adapter thing, that would be another useful technique to have in our pocket if you can work on it and get some implementation notebook that you could share.
Yeah, sure.
That'd be awesome, and I'll continue to push. So thanks, Jack, for sharing your work from last week. It's so interesting.
Yeah.
And I'll post the link.
Thanks.
Okay, thanks everybody. see you all next week.
Yeah, see you, everyone.
It is.
Take care.